Well, good afternoon, everybody. My name's Tom. I'm Tom Robinson. I have been involved in crop spraying since 1973, and in more recent years have been particularly involved in developing spray nozzles and application techniques to make, hopefully, the products work better. And that's what I really enjoy, is seeing a product work better through spray application. And the way you can improve spray application for the operator and the product is to either improve its performance or improve its convenience, and the third one is to improve its safety to operators and the environment. So my talk today will really involve all three aspects, and I was intrigued by the poll results because number one on it was water volumes, and we're going to be dealing with those as well. And the idea is to ask questions, we'll leave them till the end, but on any subject to do with spraying, as well as what I'm going to be covering today. Okay. Well, that's the what we're looking at specifically is how to set the sprayer up to get the best results from the product. And I hope that would move on.
I think you gave it the control. So if you try now, Tom, maybe you will have the control of the slides.
See.
Okay, I can do the slides, Tom. I'll do the slides. It's fine.
Okay, yeah. Back one, please, Lars.
Back one. I'll go back one.
So.
Yep.
Oh no, sorry, forwards one. We're good. Yep. Forwards one. My involvement in spray.
Yep.
My involvement in spray application. It has mainly been on crop spraying because obviously the market's huge, but it's been on both crop spraying and sports turf. And the thing I'd like to highlight in this picture, it's much more difficult to spray a golf course than it is to spray a big arable field, because golf courses undulate, and so that means the spray boom is always on the move, going up and down, and that is one of the things that makes spraying quite difficult. Modern machines, we're not going to go into the high technology end here today, but just to point out, with GPS and things like pulse width modulation, where you've got individual nozzle control, they do have great applications on golf courses. So happy to answer any questions about it afterwards. But what we're concentrating on today is the fundamentals of the sprayer setup. Next, please, Os. Where does sprayer setup fit in? Whatever you apply, whether it's on a field of potatoes or on a sports turf, you're looking for 100% control of the problem that you might have. And it could be weeds with overtake, it could be anthracnose with heritage. And I think that 100% control, which is of course unachievable, the components of it are, the product is always the single most important thing. Then the timing of application and water volumes come into that. And then the mechanical, I've called it there, but that's the actual physical setup of the machine. And then finally, the fine tuning, which is the nozzle choice in order to get everything out. So half the quality of the result is going to come from the activities of the person driving the sprayer. Next. So what we'll have a look at today are water volumes, and then we'll have a look at some nozzles, and this is all to do with setup, because that's all part of setup. And then the third bit I've called setup, that's the physical adjustments that we're going to be doing on the sprayer. And then, as Caroline mentioned earlier, I was asked to manage a trial on the application of overtake earlier on in the year. And so we tried a lot of the things that we're actually discussing today. So at the end of it, we'll have a look at what happened when we tried some of the things to get the best result that we could from the overtake. And then finally, at the end, questions on anything. I noticed that the Syngenta toolbox is steel. I'd never have a steel toolbox myself, because if you bang it on something, you damage the sprayer. But so it can be on absolutely anything. I'm happy to answer questions on. So sprayer setup 1, what water volume are you going to spray at? And what water volume gives you more coverage. And what we're really looking at, and it's very important on a golf course, is how much do you want to stay on the leaves, like you do with the herbicide, and how much do you want to run off, like you do with a soil-acting fungicide. And so to look at the effects, I've taken 2 spray volumes here, 800 litres a hectare, and 200 litres a hectare. At 800 litres a hectare, that's a high volume. You'll spread the liquid more, so it increases coverage. That may be a good thing. It may actually not be a good thing, but physically, the biggest effect it'll have, it'll increase runoff. So if we want the product on the soil, then a high water volume is a good thing to do. It decreases deposition on the leaves because it's runoff. And so again, soil-acting herbicide, soil-acting, well, any product, increasing the water volume will decrease deposition on the leaves. We don't want it on the leaves anyway. We want it on the ground, so that's great. It will also, when you increase the water volume, you decrease the concentration of the formulation, and that normally will stop it getting into the target so well, because the wetters and things there are at a less concentrated formulation. And the huge negative is it reduces work rate. So if we've got a 400 litre sprayer, we can only spray half a hectare at 800 litres a hectare. So we won't get around all the greens at 800 litres a hectare, but it's good for soil applications. Next, thanks. If we bring the water volume down to say 200 litres a hectare, and in the trials that I've done, I will always go down to 100 litres a hectare. And I haven't come across a foliar product that doesn't work at 100, I have to say. You decrease the coverage. So if you've got a contact action material that will only kill what it touches, then that might not be, might not be the best course of action. But decreasing the water volume, you've reduced the amount of runoff, so you increase the deposition of AI on the leaves. So that tends to be good for a herbicide that's foliar acting, and it's very good for any foliar acting fungicide. We've decreased the runoff, so it's great for anything involving leaves. And when we decrease the water volume, we increase the work rate, and our 400 litre sprayer would now spray 2 hectares at 200 litres a hectare. And so we'd easily be able to spray all the greens in well, half a load really, to get the job done. So decreasing water volume, it's good for foliar applications, and it's good for finishing the work on time. And remember, back to that first chart I showed you, timing is the single most important thing for getting a product to work. Next. So I take 3 Syngenta products here. We've got the growth regulator Primo Max. It's foliar acting, and its label recommendations are 250 to 400 litres a hectare. Calibra is a wetting agent, and it's recommended, this is looking hopeful, at 500 to 1,000 litres a hectare. And then it says, and follow that up with 2 to 3 millimeters of irrigation. Well, that's 30,000 litres a hectare. You're never going to put that on through your sprayer, but that will wash it on. That's what we're after. So given a choice, with the Primo Max, I'd be down at 250. And with the Calibra, well, I'd probably put it on at 800 litres a hectare. And then Heritage, that's a fungicide which controls foliar diseases like anthracnose, and then soil-borne diseases like fairy rings. So that's a bit of a tricky one. And sure enough, its recommendation is 125 to 1,000 litres a hectare. We're going to need a compromise if we're in the middle. So if you were just going for fairy rings, you'd go for the high volume. And if you were just going for the anthracnose, you'd go for the low volume. So let's simplify it and have a look at some recommendations on the next slide, please. Primo Max, as I say, it works well at less than 250 litres a hectare, but that is the volume on the label. So we go for the minimum, 250 litres a hectare. Heritage, if we're going for anthracnose and fairy rings at the same time, then we have to compromise, and I go for 400 litres a hectare. And with Calibra soil acting, I go for 800 litres a hectare. And that's the way I would choose my water volumes for the different products. So on to the issues of setup of sprayer for striping on the, well, for a golf course. A golf course is a really tricky thing to spray because of the undulations. It's what makes the golf exciting. Absolutely flat course would be really boring. And this next slide's got a build, first of all, of a sprayer on flat ground. I hope a thing looking a bit like a John Deere sprayer will appear. Yep. And there's our sprayer working. On a golf course sprayer, traditionally they have a fixed boom, and it'll be set at 50 centimeters. And so the nozzles in them run nicely at 50 centimeters and give a nice, even, uniform application like a paintbrush. But the problem that we have is golf courses undulate, and as the sprayer goes up, the boom goes down, and then that has a really bad effect on the patternation because the nozzles are really close to the ground, so you don't get the full width of the spray pattern, and we get stripes, I hope. Yeah, we get a big overdose, so we get stripes appearing on the golf course, and that's unacceptable, and all nozzles will do it. And I'd like to share with you some of the stuff we've done on nozzle developing, because traditional nozzles will actually start showing stripes quite early on when you're applying something like ferrous sulfate. And when you're applying a fungicide, you probably wouldn't see the stripe unless it scorched it or something. But if ferrous sulfate, you'll see stripes. And the fungicide, that stripe, even though you don't see it, where it's not on at the full dose, which it won't be, you won't be getting the control that you're hoping from it. So you just be disappointed with the results. So onto the nozzles, please, Lars. I'm I'm a big enthusiast of these nozzles because with some others, we designed them specially for sports turf. And they are unique because you can go down to a very low boom height and they still patternate really well. You can go actually below 30 centimeters, as you'll see, and they're still patternating really well. There's three sizes here, an 025, a 400, an 04 and an 08. And those would cover those three spray volumes I was talking about earlier very well. You need to sort out your forward speed to get it right. But their key characteristics are the low drift, 75% drift reduction. They give a uniform application, which is there's not many other nozzles, and certainly not that are specifically designed for it. They've got a small backwards angle on the tip, which counteracts the forward speed of the sprayer. So you get uniform spray front and back of whatever it is you're spraying. And they have a unique shape of tip, which enables them to patinate extremely well, right down to 30 centimeters nozzle height above the ground. Next. And another thing that we have designed into it is while they have a 75% drift reduction, they also have more drops per litre than other nozzles. So they're designed for the maximum performance in terms of the biology we can get out of them, as well as meeting the drift requirements. Next. What I'd like to show you is some of the work that we do in developing a nozzle and the effects it has on boom height. And so there you see in the laboratory at Height Pro, a patinator. You can see the row of nozzles squirting over some troughs, and then the liquid that falls into those troughs goes down into some sort of test tubes in the front of the machine. And the next slide, you can see a bad nozzle and a good nozzle together. So that's the sort of patination on the left that you get from a bad nozzle. And the one on the right, which is what we get from the XC, is really good. And in the writing on the bottom there, it says note, CV, that's the coefficient of variation, 7% line, it will be on the next graphs that you see, denotes meeting the JKI standard, and that's the Julius Kuhn Institute standard, the German standard for patination on nozzles. And I'd like to show you what happens with the fan jet, which is our traditional nozzle, and then with the Turf XC nozzles. Next one, please. So here we have what happens on the patinator when you put 110.04 fan jet in it. And you see the coefficient of variation in percent going up the left-hand side of the graph, and I've drawn that crucial line across at 7%, and we need to be below that line to have what we call a really good nozzle. It's good if 7% is difficult, but it's what you need to beat. And you see the traditional fan jet meets it at 0.5 metre above the ground, 50 centimetres, but it drops below it when it drops 5 centimetres to 450 millimetres or 45 centimetres, and down at 300 it's way off. How can we beat it? And the Turf XC is the next click of the machine, and there you see in red the patination for the 04 Turf XC, and it stays below that 7% line right down. It's only gone above it at 250 centimeters. And I hope you're sitting there watching this thinking, well, so what? And what we did was have a trial with the Sports Turf Research Institute to measure the effect of nozzle height and patination with 3 different nozzles when we're applying ferrous sulfate at standard use rate on sports turf. And I hope that goes through to our next slide. That's just showing you how we organized the trial. So we had a very direct cutoff. We ran the sprayer over boom nozzle heights from 600 down to 200. And I hope the next picture you can see what happened. And you can see some dark stripes and some with more stripes on the other. And you see there the nozzle heights are in white on the left-hand side. And we put in that 65-degree fan nozzle. It patinates really well at higher heights, but we knew it would fail lower down, so we could see it happening. And we're getting actual stripes on that at about 450 millimeters already. They're easy to see. And then the interesting one is the fan 110 degree, because you can see stripes if you look closely at 350, and in the field we could see them at 400 millimeter nozzle height. So that's a very small lowering of the boom compared with the standard 50. And then on the right, we've got the Turf XC. You can only really see them when we're down at 200. And it's great. That's what we were after in the design of the nozzle. So very tolerant of nozzle height. And on to the next slide, please. And now you can see here actually is a picture of a sprayer in action and the difficulties that we all face when we're spraying a golf course, and that we get an uneven pattern if the spray boom dips, and then at the other end of the spray boom is off the ground. And if your nozzle height goes up from 50 centimeters to 60, the spray drift doubles from it. It's huge, the effect of a small increase in nozzle height on what happens to spray drift. So I hope we're just about to see a video, and on the video the things I'd like you to look out for are that to take a patinator out into the field, we used we set the sprayer on a green with the nozzles at 50 centimeters above the green, and then we put two perspex troughs underneath it, one directly underneath the nozzle and one directly in the middle between the nozzles, and you'll see what they collect. So they're 20 centimeters high, these troughs, and that effectively means the top of the trough is 30 centimeters underneath the nozzle, to give you the idea of it. Yes, please, Lars. Okay, on to the next slide, please, Lars. I think that shows you yeah, how they perform in the field. And my recommendation would be these nozzles for sports turf. There are plenty of other nozzles. I have to say, all nozzles work, but I like these because they will consistently give you the best possible result, and that's why I'd recommend them above others. But other nozzles will do a job, and the next bit we'll look at is setting them up, and whatever nozzles you use will yeah, benefit from good setup. So that's quite a list here. And these are the things that I will check on every sprayer before setting off. And first of all, correct tyres. Now on sports turf, you've probably got the tyres you've got on your buggy, like in this thing here, and they'll be good. They're low ground pressure tyres. But correct tyres, you want something that's going to spread the load. And the way the tyres behave has a big effect on boom stability, because they're the suspension and the shock absorber as well. So you want the minimum tyre pressure for the maximum load that they're going to be taking. And also, you need to check the tyre pressures whenever you go out, particularly on a golf course sprayer, because if the tyre pressures are different from the left and the right, then one side of the boom will droop compared with the other side. And so you want them correct on all four wheels. The boom needs to be straight and horizontal, really important, and the boom suspension needs to be well maintained. Correct type and size of nozzles so that you're not running at too high a pressure. You want to be at the right pressure for the speed and volume that you're going to be working at. A new set of nozzles shouldn't vary in output by more than plus or minus 2%. They're allowed to vary by plus or minus 5, but frankly, that's a bad set of nozzles if there's a 10% variation between the highest output and the lowest output. We're going to look at these nozzles vertical in the check valve. You'll see what I mean. And they need to be vertical when you look down the boom. Nozzle height, and that's the tip of the nozzle, should be 50 centimeters above the crop of the grass. And I like to have a sprayer with a zip tie on the end set at that 50 centimeters so I can keep an eye on it and it hasn't changed. And then we finish off by doing a high pressure test for leaks. So now we'll run through those things in a bit more detail. Yeah, tyre pressures. This will affect the boom stability and the angle of the boom. So maximum pressure for the minimum load, and they should be set to what the manufacturer recommends. And yeah, same on the left-hand tyres as on the right-hand tyres. That has a big effect on boom stability. Next. If your boom moves, as in it's got a pivot in it, they all need to be working like the manufacturer thought they were when it left the factory. So every joint on the thing needs to be lubricated so that where it's meant to move, it moves freely. If it's rigid, it's not getting the best performance out of it. So lubricate all the joints on the boom. The thing needs to be calibrated properly. I always start off with a measuring cylinder for calibration, not a jug. A jug's too wide, and we're talking about quite fine measurements. So you need a narrow tool measuring cylinder to get things right, and it is the most reliable thing. There is an electronic device I've been using recently called a spot-on calibrator, which makes it really quick, and the spot-on calibrator is accurate. So it's the only machine I've come across that does work, that makes it quicker, but you can fool it as well. If there's any foam in the spray, then it fools the spot-on calibrator. So the safest method of checking a calibration is with a measuring cylinder. And yeah, you have to work out what should be coming out of the nozzles and then check it at the pressure. And I always set it up to be slightly underdosing, because somewhere or other you're going to lose a bit. So I typically be, if I wanted an output of 1 litre a minute, if I was on 0.97, I'd be pretty pleased with that. Whereas if I was on 1030, 1.03, I'd knock the pressure back a bit. Always slightly under and slightly over. Next. When do you change nozzles? Well, first of all, you see that photograph there. If you've used the Turf XC nozzles, you'll notice they've got 2 lugs on top, and you'll see them again in another slide. And I put that in. They're there so you can grab the center of the nozzle with a pair of pliers and pull it out if it needs cleaning. And the other reason for putting that photograph in is there's 2 bits that wear on any of these air inclusion nozzles. It doesn't matter if it's Syngenta, T-Jet, Lechler. You have a pre-orifice which sets the flow rate, and you've got a secondary orifice which is an ellipse which makes the pattern. So it's quite possible that the secondary orifice, the elliptical one, gets damaged, and then you'll get a poor spray pattern. So the first thing is, when you run up the sprayer in the yard and look at it squirting, if the patterns don't look good, then the nozzle's damaged and you need to change it. If you've been fortunate and nothing's got damaged, those nozzles can last for a very long time. And so then the only way to check it, if everything's working well, is to periodically put a new nozzle back in the array on the boom, and check the new nozzle or the old nozzles against the new one. Once the output's gone up by 4%, then you should change them all. So poor pattern, change them, and if the output goes up by 4%, change them. At golf courses and sports turf, they can cause significant damage to nozzles if you're using solid trace elements, things like, well, bitter salts, magnesium sulfate. It's like putting grit into your sprayer. It's like putting stones through it. And I was talking to one guy who used 3 sets of nozzles in a season because he was wearing them out with magnesium sulfate. So if you're putting solid trace elements through the sprayer, then they will wear quickly. No question about that. If you're not, liquid trace elements don't wear nozzles particularly, and if the water's clean, they can last many seasons. It's what goes through them that damages them. Next. Little things here, but they make a difference to the patternation and the way the spray behaves. The nozzles need to be vertical, and they're designed to be vertical. And once the turret gets worn, it's quite easy that they don't sit square like they did when they were brand new, and that will upset the patternation. So on the left, we need to make sure that they've clicked into their position vertically. And then the other thing that happens on sprayers is they've simply never been put straight, sometimes from when they leave the factory. So they're pointing slightly backwards or slightly forwards, and then you don't get the best uniformity of deposition. A fan nozzle, when it's working and is vertical, if it's a normal fan jet, it's squirting downwards. The spray mainly goes downwards, but because of the forward speed of the machine, a significant amount is actually moving forwards, and so it'll tend to spray the front of everything. And with those Turf XC nozzles, they've got this small angle backwards to counteract that, to make the spray drop evenly. So they really want to hang vertically. Next. And you can see that there, that's the agricultural one. On the left, you can see that the slot where the liquid comes out is canted very slightly backwards to get that effect. And when you put the nozzles into the sprayer, if should you be using Turf XCs, it means they've got a right way round, the correct way round to fit them. And I hope you can see in the picture here, there's a tiny little dot on the tip of the nozzle, and the Syngenta logo is on the front. So when you've fitted them, make sure you can see the logos are all the same way around. On the back it says Turf XC, so it's quite easy to see, but that's important. Next. We talk about nozzle height and boom height. It is nozzle height. The crucial thing, that 50 centimeters, 500 millimeters or half a meter, is from the very tip of the nozzle to the ground, and as it shows in that picture there. And as I say, I like to have a cable tie on the boom, and the reason why you see two cable ties on that John Deere sprayer, because the sprayer we used there didn't have a boom stop, so it didn't, there was nothing. You could fold the boom up and you could fold it out, and you could overfold it out so that the tip was below the main bit. So we put two cable ties on so we could see that it was level on the inside of the boom as well as the outside of the boom. Ah, now I've lost the presentation. Oh, we're back again. Excellent. Next slide, please, Lars. And our final thing here is to I always do a high pressure check for leaks, and 5 bar pressure will sort the sprayer out. You'll find out if stuff, if material's leaking. If it's not leaking, we're ready to go. And next one. And the other thing that can happen is that's the high pressure test. Unfortunately for us, we can't do a low pressure test. And I think most operators have found a problem at some time with foaming in the spray tank. And the usual cause of foaming in the spray tank, well, the easy cause of foaming in the spray tank, which all of us have done, is to leave the induction hopper open once we've put the product in, and then it sucks air in, and then you get foaming in the spray tank. But assuming we've made that mistake once and we're not going to make that mistake again, then the cause of mystery foaming, you get something foaming up, is usually an air leak, and it's an air leak on the suction side. And the typical place where you get air leaks on a sprayer is from the main filter, which has got an air leak. It's simply not, it's not sealing properly when it's been done up. And you won't see it because, of course, it's sucking inwards. And the thing I found that helps me preparing a sprayer, any of those sort of joints where you've got things that screw together and then there's an O-ring on the inside, I put silicone grease on them, and that helps you do up the thread, and it helps seal the rubber seal on the inside. And the big thing about silicone things is they don't attack rubber and they don't attack plastic. So other materials we have, like WD-40, which will get you around a bit of a problem, they've got a solvent effect, so they're not really very good. Well, I don't like using them on plastic or rubber or anything. And the other useful product is a silicone spray, which is pure lubricant. It's got no solvents in it. And again, that can be really helpful if you're fitting a new set of nozzles and the caps and the rubber are stiff and things like that. I always spray them with silicone spray before fitting them, and then they go on really easily. And again, screw fittings and hose pipes and things makes them much easier to put on. Okay, so that's our setup, and there are 11 points and to get right, and we put all 11 of them into this overtake safety trial. which I was asked to organise back in the autumn. And what we were doing here was testing it for safety and efficacy. So next slide, please. So Overtake, it's a broad-leaved herbicide, and it has a label recommendation for application of 120 up to 400 litres a hectare. So we tried all the label recommendations, and what we wanted to do, it started off as a crop safety trial, but while we're doing that, we might as well see how well it works on the weeds. So the product was tested for weed control as well at 120, 200 and 400 litres a hectare. Next. That's to show you the nozzles we used. We used the Turf XCs, the 025, the 04 and 08 for our 3 water volumes. And we were on the fairway, so we were going 8 kilometres an hour, and that worked out at 2 bar pressure exactly for putting it on. And you can see we used Overtake at 2 litres a hectare, which is the maximum label rate, and then we doubled the rate for the crop safety, and that's how you do crop safety trials. Yeah, should be safe at double the rate. Next. Lovely spray day, and yeah, warm and calm. Next. When we sprayed those 3 water volumes, I put in the plot, one of the 3 reps, a block of water, a piece of wooden batten with some water sensitive paper on. And you can see the things that what happens in theory was happening in practice. So on the left, we've got 120 litres a hectare. We'll have actually probably the most chemical on there, but you can see yellow where we haven't got coverage. You know, there's gaps between the drops. Then the middle one is 200 litres a hectare, and that's fine. You can see it's pretty well spread and the drops are actually merging. And then on the right, well, that's 400 litres a hectare, it's flooded it. We don't ever want that for a foliar acting thing because it means it's falling off the leaves and going onto the ground. Next slide, please. Oh, just showing you that we did different assessments of the different water volumes. You can't see a huge amount from those slides, except actually some leaves around the right-hand one, which was the 400 litres a hectare. Onwards. That's a graph, 2 graphs, it's not very exciting. If you do put it on at twice the dose rate, it will work marginally more than it did at the standard dose rate, but those are sort of what you'd expect. But what I wanted to show, we're getting pretty good results. Well, we're getting cracking good results at all water volumes, 400, 200 and 120 litres a hectare. But actually, if you look on the very left one, the when you add the numbers up, the 400 is not as good as the 120 and the 200's marginally better than the 120. So onward, next one. That's to give you some idea of what we were up against. That's at the last assessment. That's the weeds that were in the untreated bit. So it was a tough test for the Overtake herbicide. Next. 400 litres a hectare. It's the one thing that it was less good on than the others was, noticeably so, was its effect on speedwell. So, next. My conclusions for the trial are, next one. Overtake was safe. We had no sign of any damage on any of the treatments at 2 litres and 400 litres a hectare, and at any of the water volumes, 120, 200 and 400 litres a hectare. It's particularly effective on clover, dandelions and ribwort plantain, but it controlled all of the diseases there. It was effective at all water volumes. You could spray it at any of those, 120, 200 or 400, it will work. but it didn't benefit from the higher water volume of 400 litres a hectare. So you'd be slow. And it performed very well at 120 litres a hectare. So next slide. And if you click it one more time, back to our blocks of wood, they actually demonstrated what I was trying to say about water volumes earlier on. If we work at the 120 to 200 litres a hectare, that is what we want for foliar acting products, because we've put more chemical on the leaves. There's more active ingredient on the leaves. That can easily have helped the performance because the concentration is greater. It actually helps get the product through the leaf waxes. We've got much less runoff, so of course we got more on, we're going to get a better result. And very importantly, we increase the work rate. And the work rate at 120 litres a hectare is going to be about 30% greater even than 200. So those lower water volumes, good for foliar applications. 200 was very good, 120 was good too, and very good for finishing the work on time. Next. So recommendation, apply overtake in 200 litres a hectare. That was the very best application. But if you're in any doubt about time and things to get the stuff on, then go to 120 litres a hectare because it works really well. There was no herbicide performance benefit from increasing the water volume above 200 litres a hectare. So I would discourage its use on fairways and greens at 400 litres a hectare, because actually it just won't work as, you know, won't work to the best of its ability. Next. So that brings me to the end of my formal part of the presentation, which I hope has been useful to you. I hope a lot of it has been revision, really. We had a look at water volumes and the effects of going up in water volume or down in water volume. Really, it's straightforward. For foliar acting products, you want to keep the water volume down, and for soil acting products, you want it to go up. And we have recommendations that will go from 125, 200 and up to 800 really. Nozzles, I don't mind what nozzles you use, but my recommendation would always be those Turf XCs. They've done very well in the 8 years or so since they've been introduced, and because they're so insensitive to nozzle height. The setup of the sprayer, you will get huge benefits from. Anything you can do to make sure that spray boom is horizontal and always operating as close as possible to 50 centimetres above the ground, you'll get a benefit in weed control, disease control, and no stripes. And then we had a look at putting some of that into practice, which with the application of overtake.
Tom, first of all, thank you so much for doing the presentation.
My pleasure.
I hope a lot of guys on. I really hope you enjoyed Tom's presentation. I did anyway. And your 40 years of knowledge, of experience, of everything inside this application technology, I think it's for us, it's really valuable, and for you sharing it to us as well. So thank you so much, Tom. But you might be asking you again, Tom. So
that's right.
You might not get away so easily, but maybe next time. Let's see. Okay.
Sure.
So yeah, thank you very much again, Tom. Yeah.
Have a good rest of your meeting, guys.
Thanks, Tom.
Cheerio.
Cheerio.